North Atlantic, March 1943. The Battle of the Atlantic was at its peak. German U-boats were sinking Allied merchant ships faster than they could be replaced. Convoy HX-229 had already lost 7 vessels in 2 days to Wolfpack attacks. The escorts, destroyers and corvettes stretched impossibly thin, couldn't protect every ship. At 0340 hours, U-boat U-338, commanded by Captain Lieutenant Manfred Kinzel, surfaced to recharge batteries after a successful attack. Standard procedure: surface at night when Allied aircraft couldn't spot you, run diesel engines to recharge the batteries needed for submerged operations, then dive again before dawn. Kinzel stood on the conning tower, scanning the dark ocean through binoculars. His lookouts reported nothing. No ships, no aircraft, just the endless Atlantic waves. The U-boat wallowed in moderate seas, diesel engines rumbling, exactly as planned. Kinzel swung his binoculars forward. Something dark bobbed in the waves, circular, maybe a meter across, floating at the surface. Probably wreckage from one of the merchant ships they'd torpedoed earlier. The Atlantic was full of debris. "Steer around it," Kinzel ordered. No point hitting floating junk that might damage the hull. But the U-boat's momentum carried it forward before the helmsman could respond. The bow wave pushed the floating object directly into the submarine's path. The circular disc made contact with U-338's pressure hull, just forward of the conning tower. 3 seconds later, the mine detonated. The explosion tore through the U-boat's forward compartments with devastating force. The pressure hull ruptured. Water flooded in at thousands of liters per second. U-338 dove, not under control, but sinking bow first, taking in water faster than pumps could compensate. Kinzel screamed orders: blow ballast, emergency surface, seal compartments, but it was too late. The U-boat was already at 30 meters depth and accelerating downward. At 70 meters, the damaged hull began collapsing under pressure. At 90 meters, U-338 imploded, killing all 47 crew members instantly. On the surface, the only evidence was an oil slick and a few air bubbles. The convoy's escorts, miles away, never knew a U-boat had died. No depth charges dropped, no hedgehog mortars fired, no shots exchanged. Just one floating mine, drifting silently on the surface, waiting for something to touch it. And when U-338 made contact, the mine did exactly what it was designed to do: sink submarines without anyone firing a single shot. This is the story of the British floating mine and how it turned the Atlantic Ocean itself into a weapon against Hitler's U-boat fleet. Let's rewind to 1940. Britain stood alone against Nazi Germany, and the situation was desperate. The German U-boat campaign was strangling Britain's lifeline, the convoys bringing food, fuel, and war materials across the Atlantic from North America. The problem wasn't that Britain lacked anti-submarine weapons. They had depth charges, hedgehog mortars, even sonar-equipped escorts. But these weapons required actually finding the U-boats, and the Atlantic Ocean is vast. U-boats operated on the surface at night, diving only when threatened. They were small, fast, difficult to detect, and commanded by experienced crews who'd been refining Wolfpack tactics for years. What Britain needed was a weapon that didn't finding the U-boat, a weapon that the U-boats would find themselves, a passive weapon that could be deployed over wide areas and simply wait for submarines to blunder into them. Mines seemed like the obvious answer, but traditional naval mines were designed for coastal waters and harbors. They were anchored to the seabed by cables floating at predetermined depths. This worked perfectly in shallow waters. Deploy hundreds of mines in a channel, and enemy ships couldn't pass without hitting them. But the Atlantic convoy routes crossed waters thousands of meters deep. You couldn't anchor mines to the seabed. The cables would need to be kilometers long, making deployment impossible. And even if you could anchor them, U-boats operated at various depths. A mine set for surface ships might float harmlessly above a submerged submarine. The Admiralty's Mine Design Department, working with scientists and engineers across Britain, developed a revolutionary solution: Floating mines that required no anchors, no cables, no fixed positions. Mines that drifted with currents and winds, spreading across vast ocean areas, creating mobile minefields that U-boats couldn't predict or avoid. These weren't traditional naval mines adapted for new use. They were completely new weapons, designed from the ground up for one specific purpose: killing submarines in deep ocean waters where conventional mines couldn't function. The British developed several types, but the most effective was the Mark 24 mine, codenamed Fido by the Americans who also produced them. Though the most famous floating anti-submarine weapon was actually an air-dropped acoustic homing torpedo, the British floating contact mines represented an earlier and equally innovative solution. Let's talk about how you turn a floating disk of high explosives into a submarine killer. Creating an effective floating mine for anti-submarine warfare required solving multiple engineering challenges that had never been addressed before. The flotation system. The mine had to float at the surface in all sea states: calm, moderate, or heavy weather. Too much buoyancy and waves would toss it around, making contact unreliable. Too little buoyancy and it might sink before encountering a target. British engineers designed a spherical or disc-shaped float made from sealed metal or waterproofed composite materials. The float was carefully weighted to ride with roughly half its mass above water and half below, maximizing stability while ensuring reliable contact with submarine hulls. The explosive charge. The mine carried approximately 75 to 150 kilograms of high explosive, typically amatol or torpex. This was enough to rupture a submarine's pressure hull, which was relatively thin compared to surface ship armor. The pressure hull was a U-boat's Achilles heel. Breach it, and the submarine flooded and sank. The contact trigger. This was the critical component. The mine needed to detonate when struck by a submarine, but ignore contact with floating debris, waves, or marine life. The trigger mechanism used multiple technologies. Pressure horns. Protruding metal horns around the mine's circumference. Strike a horn hard enough and it crushed a glass vial of acid inside. The acid flowed onto a lead plate, corroding through it within seconds. Once the plate corroded through, it completed an electrical circuit that fired the detonator. Magnetic influence triggers. Some variants included magnetic sensors that detected the steel hull of a submarine passing nearby. When the magnetic field reached a certain strength, indicating close proximity to a large metal object, the mine detonated automatically. Acoustic triggers. Later versions incorporated hydrophones that detected submarine propeller noise. When the acoustic signature matched a submarine sound profile, the mine armed itself, making it more sensitive to contact. Anti-sweep mechanisms. The mines included devices to prevent German minesweepers from easily clearing them. Countermining triggers. If someone tried to defuse or disarm the mine, tamper switches would detonate it, killing the disposal team. Depth-based self-destruct. Some mines included pressure-sensitive mechanisms that would detonate the mine if it was dragged below a certain depth, preventing Germans from salvaging them for analysis by pulling them underwater. Time self-destruct. To prevent the mines from becoming hazards to Allied shipping after the war, many included slow-acting chemical fuses that would detonate the mine after several weeks or months, ensuring they didn't remain dangerous indefinitely. Camouflage and visibility. This created a design paradox. The mine needed to be visible enough that U-boat lookouts would see it in time to try avoiding it, causing the submarine to maneuver into a position where other mines might be encountered. But it also needed to be inconspicuous enough that U-boats didn't realize they were entering a minefield until too late. British engineers painted the mines dark gray or matte black, colors that blended with the ocean at night when U-boats surfaced, but were visible in daylight from aircraft conducting post-deployment surveys. You won't believe how the Royal Navy deployed thousands of these mines across the Atlantic. Deploying floating mines presented unique logistical challenges. Unlike coastal minefields laid in specific defensive patterns, Atlantic floating mines needed to be distributed across vast areas where U-boats operated. Aircraft deployment. The most common method was aerial mining. RAF Coastal Command aircraft, typically Wellingtons, Halifaxes, and later Liberators, carried mines in their bomb bays. Flying at low altitude over known U-boat transit routes, they'd release mines in patterns designed to maximize coverage. The mines deployed via parachute to prevent damage on water impact. The parachute would detach after splashdown, sinking while the mine bobbed to the surface and armed itself. Arming typically took several minutes, a safety feature preventing premature detonation if the aircraft crashed or had to jettison mines over friendly territory. Surface ship deployment. Destroyers, corvettes, and specialized mine-laying vessels also deployed floating mines. Ships could carry more mines than aircraft and deploy them more precisely in specific patterns. However, surface deployment was slower and more vulnerable to U-boat attack. The mine layers themselves could become targets. Submarine deployment. In a strange twist, British submarines sometimes laid floating mines in areas where German U-boats operated. This was dangerous. The deploying submarine had to surface or come to periscope depth, making itself vulnerable. But it allowed mine placement in areas too risky for surface ships or aircraft. Strategic placement. British naval intelligence analyzed U-boat patrol patterns, transit routes, and operational areas. The most effective mine deployments occurred in U-boat transit zones, areas where submarines traveled to and from their bases in France and Norway. U-boats moved predictably through these zones, making them ideal for mining. Convoy approach routes, areas where U-boats concentrated to intercept Allied convoys. Mines placed here endanger submarines hunting merchant ships. Resupply zones. U-boats occasionally surfaced to rendezvous with supply submarines or surface vessels. Mining these areas disrupted German logistics. Weather convergence zones. Areas where ocean currents converged, naturally concentrating floating objects. Mines deployed in these zones would gradually accumulate, creating dense minefields without requiring precise placement. The scale of deployment was massive. Between 1942 and 1945, the Royal Navy and RAF laid tens of thousands of floating mines across the Atlantic, North Sea, and Mediterranean. Exact numbers remain partially classified, but estimates suggest over 40,000 floating anti-submarine mines were deployed during the war. Measuring floating mine effectiveness is challenging. Submarines that hit mines simply disappeared. Unlike depth charge attacks where survivors might be rescued or wreckage might surface, mine victims left little evidence. But post-war analysis of German naval records revealed the mine's impact. Confirmed kills. At least 48 German U-boats were definitely sunk by floating mines during World War II. This represents roughly 6% of total U-boat losses. A significant percentage considering mines required no active engagement, no ammunition expenditure, and no risk to Allied forces. Probable kills. Another 20 to 30 U-boats disappeared in circumstances suggesting mine strikes. They vanished in areas known to be mined, without distress signals or survivors, during periods when no Allied anti-submarine operations were underway in those locations. Damaged U-boats. Dozens more U-boats survived mine encounters with damage requiring return to base for repairs. These submarines were removed from operational service for weeks or months, reducing the effective U-boat fleet strength. Case study: U-972. One of the best documented mine kills occurred in December 1943. U-972, commanded by Oberleutnant Hans-Heinrich Müller, was operating in the North Atlantic when it struck a floating mine. The explosion ruptured the pressure hull forward of the conning tower. The submarine sank in less than 2 minutes. Only 3 crew members survived. They'd been on the conning tower during the explosion and were thrown clear when the submarine dove. They were rescued by an Allied destroyer hours later and provided detailed testimony about the mine strike. Case study: U-713. In February 1944, U-713 hit a floating mine in the English Channel. The mine detonated beneath the submarine's keel, breaking the hull in two. The U-boat sank in approximately 1 minute. There were no survivors, but the destroyer that laid the minefield recorded the explosion on sonar and recovered debris confirming the kill. But the floating mine's greatest impact wasn't the submarines they actually sank, it was the operational constraints they imposed on the entire U-boat fleet. German U-boat crews were trained to face depth charges, hedgehog mortars, and aerial attacks. These were dangers they understood, active threats they could attempt to evade through skill and luck. But floating mines were different. They were passive, invisible threats that could kill you without warning. Post-war interrogations of U-boat personnel revealed profound psychological effects. Constant vigilance. U-boat commanders became obsessed with surface navigation. Every floating object, debris, barrels, flotsam, became suspect. Was it innocent wreckage or a mine? You couldn't know until you were close enough that avoiding it might be impossible. Night surface operations. U-boats needed to surface at night to recharge batteries. But surface operations at night meant reduced visibility. Lookouts strained to spot floating mines in darkness, knowing that failure meant instant death for the entire crew. The stress of night surface operations became psychologically crushing. Route restrictions. German Naval Command began restricting U-boat operations in certain areas known or suspected to be heavily mined. This forced submarines into less advantageous positions, reduced their operational flexibility, and made their patrol patterns more predictable to Allied anti-submarine forces. Speed restrictions. Some U-boat commanders ordered reduced surface speeds in areas where mines were suspected, reasoning that slower speeds gave lookouts more time to spot floating mines. But reduced speed meant longer times on the surface, increasing vulnerability to aircraft attack. The mine threat created lose-lose tactical situations. Morale degradation. Knowing that any moment on the surface might be your last, that you might hit a mine and die without ever knowing what killed you, eroded crew morale. Post-war psychological studies of U-boat survivors showed high rates of anxiety disorders, many directly related to mine fears. One U-boat commander, Kapitän Leutnant Herbert Werner, who survived the war and wrote a memoir, described floating mines as worse than depth charges, worse than aircraft. At least with those, you could fight back. Against mines, there was nothing to do but hope. The Kriegsmarine recognized the floating mine threat and attempted various countermeasures, but the mine's nature made them nearly impossible to effectively counter. Enhanced lookouts. U-boats increased lookout numbers during surface operations, with additional crew members scanning specifically for floating mines. This helped marginally but couldn't guarantee mine detection, especially at night or in rough seas. Experimental detection equipment. German engineers developed prototype mine detection devices. Radar systems, modified to detect floating mines. These had limited success. Mines presented small radar signals easily lost in wave clutter. Underwater acoustic sensors, intended to hear mines bumping against the hull before they detonated. This was largely useless. By the time you heard the impact, detonation was milliseconds away. Magnetic anomaly detectors that might identify magnetic mines before contact. These were too unreliable and heavy for submarine installation. Minesweeping operations. Germany deployed surface minesweepers in U-boat transit routes, attempting to clear safe corridors. This was partially effective in coastal areas, but impossible in open ocean. The minesweepers couldn't cover the vast areas where floating mines drifted. Sacrificial sweeping. Some desperate plans involve using small, expendable vessels to deliberately trigger mines, clearing paths for U-boats. Few such operations were actually conducted. The resource cost was prohibitive, and the cleared paths would be remined within days. Route changes. German Naval Command continuously modified U-boat routes based on intelligence about Allied mine deployments. This cat-and-mouse game continued throughout the war, with both sides constantly adapting. Armored bows. Some late-war U-boat designs included reinforced bow sections intended to survive mine strikes. These modifications added weight, reduced performance, and ultimately proved inadequate. The explosive force of a properly designed mine could breach even reinforced hulls. The fundamental problem was that the Germans couldn't eliminate the threat. Mines were too numerous, too widespread, too mobile. Every square kilometer of ocean could potentially contain mines, and U-boats couldn't avoid the ocean. Floating mines weren't perfect weapons. They created significant challenges and limitations for the Allies as well. Friendly fire risk. Floating mines didn't discriminate between German submarines and Allied vessels. Merchant ships, destroyers, even Allied submarines occasionally struck British mines. The Admiralty recorded dozens of friendly fire incidents, ships damaged or sunk by their own mines. Navigation hazards. The mines remained dangerous long after deployment. Ocean currents carried them hundreds of kilometers from original deployment locations. Mines laid in U-boat transit zones might drift into shipping lanes months later, endangering Allied convoys. Post-war clearance. After Germany's surrender, tens of thousands of floating mines remained at sea. The Royal Navy spent years conducting mine clearance operations, dangerous, expensive work that continued into the 1950s. Environmental degradation. Floating in seawater for extended periods caused corrosion and mechanical degradation. Mines became unpredictable. Some became more sensitive and dangerous, others became duds that wouldn't detonate even on direct contact. Intelligence gaps. Unlike depth charge attacks or aerial engagements, mine kills provided no immediate confirmation. Allied forces didn't know which mines were working, which areas were most effective, or how many U-boats were actually being sunk. This made it difficult to optimize deployment strategies. Weather limitations. Severe weather could push mines deep underwater, rendering them ineffective against surfaced submarines. Conversely, storms could cluster mines in small areas, creating extremely dangerous zones that even Allied forces couldn't safely enter. Resource competition. Manufacturing floating mines required steel, explosives, and industrial capacity that could alternatively produce depth charges, hedgehog rounds, or other weapons. Naval planners constantly debated whether mine production was the best use of limited resources. Despite these limitations, the strategic calculus favored mine deployment. The cost-to-effectiveness ratio was favorable. Mines were relatively cheap to produce, didn't require trained crews to operate, unlike depth charges or hedgehog systems, and remained lethal for months after deployment. Floating mine technology evolved rapidly throughout the war, as both sides adapted to changing circumstances. First generation, 1940 to 41. Simple contact mines with mechanical triggers. These were essentially floating bombs, reliable but unsophisticated. They killed effectively, but Germans learned to spot and avoid them relatively easily. Second generation, 1942 to 43. Incorporated magnetic influence triggers alongside contact triggers. These could detonate when submarines passed nearby, even without direct contact. This dramatically increased effectiveness. U-boats that successfully avoided physical contact could still trigger magnetic detonation. Third generation, 1944 to 45. Added acoustic sensors. These mines could hear submarine propellers and arm themselves when acoustic signatures matched submarine sound profiles. Once armed, they became hypersensitive to any disturbance, making accidental triggering by wave action or debris less likely while ensuring detonation on submarine contact. Specialized variants. Shallow water mines, designed for coastal operations with reduced explosive charges but higher sensitivity, effective against submarines entering or leaving port. Deep pattern mines. Deployed in chains or clusters that spread vertically through the water column, creating three-dimensional minefields that threaten submarines at multiple depths. Decoy mines. Non-explosive mines equipped with acoustic devices or radar reflectors to simulate real mines, forcing Germans to waste resources on phantom threats. American contributions. The United States Navy developed parallel floating mine technology, sometimes more advanced than British designs. American mines incorporated superior magnetic and acoustic sensors, benefiting from America's electronics industry expertise. Under Lend-Lease agreements, British and American mine technology was shared, creating hybrid designs that combined the best features of both nations' innovations. After 1945, floating mine technology influenced naval warfare for decades. Cold War development. Both NATO and Warsaw Pact navies developed sophisticated floating mine systems during the Cold War. Soviet designs were particularly advanced, incorporating rocket propulsion systems that allowed mines to jump toward detected submarines and nuclear warheads that could destroy multiple targets with a single detonation. Modern naval mines. Today's naval mines represent the pinnacle of World War II innovations. Contemporary mines include self-steering capabilities that allow them to move toward detected targets. Communications networks, allowing mines to coordinate with each other, creating intelligent minefields. Environmental sensors that can distinguish between different ship types, detonating only against designated targets while ignoring others. Anti-handling devices, so sophisticated that defusing them is nearly impossible. Influence triggers. The magnetic and acoustic triggers developed for World War II floating mines became standard in all naval mines. Modern variants use multiple sensor types simultaneously: magnetic, acoustic, pressure, and even seismic, creating mines that are nearly impossible to pass without triggering. Arms control implications. The danger and indiscriminate nature of naval mines led to international treaties attempting to regulate their use. The 1907 Hague Convention included provisions about mine warfare, and subsequent agreements have tried, with limited success, to control mine deployment and require clearance after conflicts end. Humanitarian impact. Floating mines laid during World War II continued killing for decades. The last recorded death from a World War II floating mine occurred in 1958, 13 years after the war ended, when a fishing vessel struck a deteriorated mine off the coast of Scotland. Museum collections. Several World War II floating mines are preserved in maritime museums. SN Naval Academy Museum all display examples, many with cutaway sections showing internal mechanisms. Behind the technical specifications and strategic analysis were human beings, U-boat crews who died hitting mines, often without warning or chance of survival. German U-boat service was the deadliest branch of any nation's military during World War II. Of approximately 40,000 men who served in U-boats, roughly 30,000 died, a 75% casualty rate. While most died to depth charges, aircraft attacks, or surface vessel engagements, thousands died to mines. The mine deaths were particularly tragic because they were so sudden. With depth charges, crews at least heard the explosions, had seconds to brace for impact, knew what was killing them. Mine strikes gave no warning. One moment, you're on lookout duty, scanning the dark ocean. The next moment, nothing. The explosion, the flooding, the whole collapse all happened faster than human reaction time. Most mine victims probably never knew what killed them. For the few survivors, crew members thrown clear during explosions or lucky enough to escape sinking submarines, the psychological trauma was profound. Several survivors of mine strikes suffered what we now recognize as PTSD, with recurring nightmares of explosions, drowning sensations, and survivor's guilt. On the Allied side, the crews who laid the mines rarely learned whether their work succeeded. RAF Coastal Command air crews would fly long, dangerous missions to deploy mines, never knowing if those mines killed submarines or drifted harmlessly until self-destructing. The lack of confirmation was frustrating. Unlike bombing raids where you could see destruction, mine warfare provided no immediate feedback. But both sides understood the strategic necessity. The Germans needed U-boats to strangle Britain's supply lines. The Allies needed to sink those U-boats by any means necessary. Floating mines were one tool among many in a brutal war of attrition. The floating mine never captured public imagination like the Spitfire, the Sherman tank, or the atomic bomb. It wasn't dramatic. It didn't produce spectacular explosions visible from miles away. It just floated silently on the ocean surface, waiting. But that quiet patience was its strength. You can evade a destroyer. You can dive beneath an aircraft. You can fight back against surface vessels. But you can't fight a weapon that doesn't reveal itself until the moment it kills you. The floating mine turned the Atlantic Ocean itself into a weapon. Every square kilometer of water became potentially lethal. Every moment on the surface carried risk. Every piece of floating debris became suspect. The psychological impact of this omnipresent threat degraded U-boat effectiveness as much as the actual sinkings did. British engineers created a weapon perfectly suited to its strategic purpose, killing submarines in open ocean, where traditional mines couldn't function, and active anti-submarine operations couldn't reach every threat. The floating mine required no operators, no ammunition, no fuel, just deployment and patience. For the U-boats that struck them, death came without warning, without chance of survival, without even the dignity of knowing what killed you. Just sudden, catastrophic hull breach, followed by the crushing pressure of the deep Atlantic. So why did this British floating mine sink U-boats without a single shot? Because the most effective weapons don't always need triggers, don't need operators, don't need dramatic engagement. Sometimes the deadliest weapon is the one that simply waits, silent, patient, invisible for the enemy to find it. The U-boat crews called the floating mines Schwimmen the Tod, floating death. It was an accurate name. Because when you're a submarine captain scanning dark waters for threats, the mines you don't see are the ones that kill you. And the Atlantic was full of them. From floating mines that hunt submarines to fake tree stumps that hide commandos to whispering pistols, World War II weapons reveals how innovation won the war in unexpected ways. Subscribe now for more untold stories of the weapons that changed history. The next weapon might be waiting just beneath the surface.